Welcome everyone. Today we are exploring learning in hindsight, an exciting new approach to aligning language models directly from user interactions. This research is brought to you by a collaboration between ETH Zurich, MIT, and the University of Zurich. Let's start by looking at what we call the greatest untapped resource in artificial intelligence. When we train models today, we usually rely on the tip of the iceberg, which is curated training data. This data is expensive, requires explicit labels, and depends heavily on expert demonstrations. But beneath the surface lies a massive, hidden resource: raw deployment interactions. Every single day, users generate millions of multi-turn queries, refinements, and organic corrections. Right now, inference dominates our compute, yet all of this rich, interactive data is completely discarded. This creates a massive bottleneck in model alignment. Currently, raw user conversations hit a dead end, forcing us into a friction-heavy detour. To improve a model, we have to loop through data curation, human annotation, and complex reward modeling. The core problem is that real-world user interactions don't look like standard datasets. They completely lack explicit labels, rewards, or preference scores. Instead, the feedback is entirely implicit. But here is the epiphany: in-context correction. Language models actually already know how to interpret and act upon user follow-ups. Imagine a user asks a question, the model responds with unnecessary filler, and the user replies, "Get to the point. Just answer directly without filler." If we view this through a hindsight lens, the model instantly corrects itself to provide a direct answer. This reveals something powerful. Having seen the user's reaction, the model's behavior is inherently better aligned than it was before. The model is aligned in hindsight. To capture this, we introduce Self-Distillation Policy Optimization, or SDPO. We compare the model's original policy, what it actually did, with a hindsight policy, what it would have done if it already knew the user's reaction. By looking at this difference, we generate a highly precise learning signal entirely without human labels. Positive behaviors are reinforced, and negative behaviors are penalized. Effectively, we distill the model into itself. We derive this learning signal token by token. By calculating the log ratio between the raw generation and the hindsight distribution, SDPO precisely penalizes the specific behaviors that caused user frustration and reinforces the corrected behaviors. This creates a completely organic, token-level reward. Let's look at how this changes the alignment landscape. Unlike supervised fine-tuning or RLHF, which rely on curated datasets, expert demonstrations, and extremely high labeling costs, SDPO thrives on raw deployment data from the wild. It uses implicit follow-ups as a feedback mechanism, driving the external labeling cost down to zero. This enables not just general alignment, but hyper-personalized alignment, allowing models to learn organically from their own deployment exhaust. But what about noise in the wild? SDPO acts as a natural noise filter, providing incredible robustness. When a user gives relevant feedback, like asking to rewrite an email in a professional tone, the model updates and adjusts the specific tokens involved. But if a user follows up with an unrelated question, like "What is 27 times 4?" the model naturally suppresses the learning updates. It only learns when there is a valid, actionable signal. The results speak for themselves. We achieve general alignment without regression. Even when trained on fully uncurated, noisy user interactions, SDPO consistently improves alignment. We saw broad gains on Alpaca Eval, IF Eval, Arena Hard, and MMLU Pro using a Qwen 3-8B baseline. Crucially, this improvement doesn't degrade math, coding, or knowledge tasks. So, why does SFT fail in the wild where SDPO succeeds? SFT uniformly reinforces everything in a dataset, which includes the exact mistakes that led to the user's frustration in the first place. SDPO, on the other hand, makes surgical, token-level updates. Its comparative advantage explicitly decreases the probability of failure modes, sending performance steadily upward. Beyond general alignment, SDPO enables instant personalization, word by word. Imagine a user prefers concise, casual, and beginner-friendly answers. Without any explicit user profiles or settings menus, SDPO molds the model to the user's latent preferences. In fewer than 100 conversational turns, the win rate leaps from 50% to over 95%. It also offers remarkable cognitive agility. What happens if user preferences abruptly change? If a user suddenly wants detailed and professional answers, outdated preferences are rapidly unlearned because they no longer align with the new interactions. The model simply pivots on demand, living in a state of continuous adaptation. SDPO also features complex memory, allowing for the layering of preferences. Over time, a user might indicate they don't like emojis, want less filler praise, and prefer direct answers. SDPO accumulates these complementary preferences over time. It weaves a complex behavioral profile without forgetting previously learned instructions. This brings us to the continual learning flywheel, where inference fundamentally is training. The cycle is simple. A user prompt leads to a user reaction, which triggers our hindsight update, ultimately resulting in better generation. We no longer need to halt deployment to improve the model. The latent reward function of the user is optimized simply by letting the user talk, collapsing the separation between the lab and the wild. Welcome to the closed-loop era. It is built on 3 pillars: zero-cost alignment, which discards the need for expensive external labeling because the data is already there; interpretable signals, where token-level log ratios provide mathematical proof of what the model is learning; and living models. AI is no longer a static artifact shipped in versions. It continuously personalizes and adapts to individual humans through the simple act of conversation. We are finally aligning from the wild.